welcome to another video in the Industrial Instrumentation series. In this video, we will be covering the very basic aspects of PLC programming with preference to learning the basics of ladder programming software. The study will be done on a beginner level and we will do the realization of basic gates with ladder programming as well. For advanced and logical programs will be realized in the upcoming videos, which will include counters, timers and other logic operators. And as suggested in the outline, we will be looking at the various programming methods or languages used to program a PLC, then move on to the basics of ladder programming, and then the rules. And finally, we will realize a few basic gates like AND, OR, and NOT. Let's move on. First of all, let's see what are the different programming languages that are available for programming a PLC. To make a list of it, let me tell them one by one. The first is instruction list, then structure text, sequential function chart, function block diagram, and last, ladder diagram itself. Instruction list, just as the name suggests, is a list of instructions that the PLC has to execute sequentially in order to perform the assigned function. Let's have a look at a sample code. Here we can see there is a 3-statement code. The first statement is LDA, which loads a value into the register A. The second instruction AND B does the logical operation AND on A and B. And third instruction ST space Q stores the above result into a new location named Q. So this is how basically an instruction list works. Now let's move on to the next one, structure text. Structure text is more of a high-level language and is designed specifically for industrial purposes. It is similar to Pascal or BASIC, and it follows a straightforward and easy-to-use format which gives very simple solutions for difficult problems. Next one is sequential function chart. And sequential function charts are a graphical programming language. And being a visual programming language, it means that it is well suited to the task of breaking down a large and complex process into smaller pieces that are easier to see and understand than with solely text-based programming. So as you know, with block diagrams and flowcharts, what it does is it makes the solutions much more simpler and easier to understand and comprehend. And the fourth one is a function block diagram. The function block diagram is also a graphical type of language and describes the function between inputs and outputs that are connected in blocks by connection lines. For example, in the first type of programming language, say instruction list, to do the logical operator AND, what we did was to write a code AND B and A, something like that. In the case of a function block diagram, what we do is that we can see that there is a block which is used for the logical operation and this block has the code of logical operation AND inside that. And what we need to do is we need to assign 2 inputs to the block. The output will naturally be the logical AND operation of the 2 inputs. So this block can be used again and again in the program without having to write the same code. We can just copy and paste the block. Okay. And finally comes the ladder diagram. From the figure itself, you might know that why it is called a ladder diagram, because it pretty much looks like a ladder with horizontal and vertical bars. These vertical bars are known as rails and the horizontal bars are known as rungs. And this is where we do the logical programming. We can see that there are basically 2 parts here, the input and logic section and the output section. So the input and logic section is where we use the switches, and where this is the place where we apply the logic like timers or whatever kind of logic we need to apply. This is the place. The left hand side is the place where we implement the logic, and the right hand side is where we get the output. Okay, so this was an introduction of the different programming languages that are available, and as you can see there are basically 5 types. And what we are going to focus in this video will be ladder diagram and only the very basics of ladder diagram. Now let's have a look at the ladder diagram basics. And as I've mentioned earlier, we are doing this on a very beginner level, so we will be only doing very simple logics just to make you understand how the functioning of a ladder diagram is. And to do this, we are going to just light up a lamp using a switch. And mentioning about switch, we can have contacts instead of switches in case of a ladder diagram. And there are basically two types of contacts. One is NC contact, or normally closed contact, and the other one is an NO contact, or normally open contact. And I will just make an illustration on how this basically works. See, just consider I have placed an N or normally open contact on the ladder diagram, and I have connected an output. And if the logical state of this NO contact is 0, the output is also 0. That is, it does not light up. Okay. And if the logical state of this input, or if this switch is on or high, the output will also be high or on. So basically, the dormant state of an NO contact is off and the high state is on. The next one is a normally closed switch. This is different in a way because the dormant state or the logical zero state is high. That is, if we connect a light to a normally closed contact, even when the switch is off, the light will be on, and when we turn on the switch, the light will turn off. And this is the basic idea of an NO contact and an NC contact. And we have two other types of contact mentioned here, which are NO push button and an NC push button. A push button is nothing but the output may be low or may be high. It only stays as long as we have kept a pressure on the push button. Once we release, it comes back to the original state. And on the right side, to indicate the outputs, we have used coils. Okay. Now this slide basically shows how it is implemented in practical. So we will deal with this in detail in the coming videos. So we'll just move on to the programming rules. So there are many rules when it comes to PLC programming. So what we are doing here, we are only looking into very basic rules that are needed to program very simple programs, like maybe turning on and off a light, or maybe implementing basic logical gates and such. We'll be looking only into programming rules that are required for the same. Okay. And the first and foremost rule is that we can only use the input on the left side and the output on the right side, and it cannot be the other way. Okay, the input should always be on the left and the output should always be on the right. And the second one is that the input switches can either be connected in parallel or series, but the output can only be connected in parallel. Okay, the input switches can be connected in either parallel or series, but the output can only be connected in parallel. We will be looking at the details of this in the coming slides. Okay. The third rule, the output coil address can be used only once to represent an output location in the whole program. That is, we can have multiple input switches having the same address A, but the output X, the output address X can be used only once as the output. But the other fact is that this X or this output address X can be used as the input of another run. I shall repeat myself. While doing a ladder program, we cannot use the same output address in more than one run as an output, but we can use the address of an output as the input of the next run. Okay, so these were the 4 basic programming rules that we had to look at. And there is one more thing we need to look into before we go into realization of the ladder program, and this thing is scanning. Scanning is basically how a PLC reads the instructions. And there are 2 methods by which a PLC reads the instructions. The first one is horizontal scanning and the second one is vertical scanning. In horizontal scanning, the PLC program is read rung by rung from the left hand side to the right hand side. First rung from left to right, then second rung from left to right, then third rung from left to right. That is how the horizontal scanning goes. And the second one is vertical scanning, and in vertical scanning, ladder logic is read from top to bottom direction, and thus each rung is read at the same time column by column. Okay, so now we have the basic idea of what are the switches and what are the type of outputs that can be used in a PLC. We know the basic rules that has to be used while programming a PLC, and we know how we does scanning or how we does the programming or how the PLC reads the programs. And now we will move on to realization of a few basic gates to gain a better understanding of how PLC programming works. And the first gate we choose is an OR gate. So we are all familiar with an OR gate, and to sum it up in a single word, an OR gate, in an OR gate, if any one of the inputs is high, the output should be high. Just consider a light. We have multiple conditions and multiple switches are to be used to turn on a single light. And these two switches can be used independently. In such a case, we use an OR gate. We will just demonstrate that using the example. So I have a ladder diagram and I have two switches A and B and a single output X. Okay, and the first condition is both the switches are off. That is the logic condition 0, 0. In this condition, both of them are off and the output doesn't work. Okay, the second condition is 0, 1. That is the second switch is in high state. In this condition, we can see there is a logical path or it's a current conduction path from the left hand side to the right hand side, and therefore the switch will be turned on. And the third condition is 1, 0, where the first switch is in a logical high condition, and you can see it still conducts. And the fourth condition is both the switches are turned on, and obviously you can see that there are two conducting paths. The current might pass through any one of them and the output will be high. Okay, so that's with OR gate. Now let's move on to the AND gate. And again, summing up AND gate in a single sentence, only if both the inputs are high, the output should be high. Say, for example, you want to light up a room and you have a single light, but there are two conditions to be met. The first thing, if the light has to be turned on, it has to be night and a person has to be in the room. So these two conditions has to be satisfied and in such a case we can use an AND gate. And let's just analyze it. I have a ladder diagram and I have connected two switches in series and also an output. And the first condition is 0, 0, that is both these switches are off. Obviously the output is also off. The second condition is one of the switches is high, say the first one. But the problem here is even though the first one is on, the second one is off and therefore there is no complete conduction path. And this is exactly the same thing that happens with the third condition also. We have one switch off and the one switch on, and therefore there is no clear conduction path and the output is still off. Only when both the two switches are off, that is in the fourth condition, logical condition 1, 1, the output will be high because both these switches will be conducting and the output will also be high. So this is how we realize an AND gate. Okay, the last one is a NOT gate. And a NOT gate, as we all know, is a negation of the input. That is, whatever we given as the input, the output should be the opposite. Okay, so to implement this, what we use is a normally closed switch. And I have mentioned earlier that a normally closed switch is one where when the logical situation or the logical condition is 0, the switch conducts, and when the logical situation is or the condition is high, the switch doesn't conduct. So this property can be used as a NOT gate. So to summarize the realization of these three gates using PLC programming, we can just list them as these 3 points that are given below. Parallel contacts are equivalent to an OR gate. Series contacts can be considered as equivalent to AND gates, and a normally closed contact is equivalent to a NOT gate or an inverter. So this is all what is included in this video. In the upcoming videos, we'll be doing PLC programs based on counters and timers.